Okay, so here we are going to use line integrals. So these are applications to computing work of a force. So imagine that you have a force which is given in vector form. And so it's negative 5x squared and 6xy. Okay, so at each x and y, this is the force. And then the particle is moving along some sort of curve C. Okay, so this is a line integral. So this is not a straight line segment, right? This is some sort of curve with a given parameterization, which we're going to do in a second. So what's happening? Generally speaking, work, if you remember, is force multiplied by distance. Okay, but here it's not going to be quite that simple because first of all, force is not constant, it changes, and the distance is along a curve, right? It's not like a straight line or anything like that. So in this case, what happens is we're going to get a line integral over that curve, and this is going to be force dot, which is the dot product, which is something called dr, which is the vector basically that consists of change of x, change in y, change in z if needed. So this is going to be like dx, dy, dz if it's a three-dimensional situation. Okay, so what will that actually become? So imagine that the force is given by some P, Q, and R, three components. So what happens then when we dot it with dr? So if this is P, Q, R, dot with dx, dy, dz. So when we do that, we are going to just dot product it, right? So P will be multiplied by dx, Q will be multiplied by dy, and then R will be multiplied by dz. So this is a formula for work of a force, how we connect it to a line integral over that curve that a particle is traveling, okay? So by the way, they want me to make a parameterization for a circle with radius 7. So that should be 7 cosine t as 7 sine t, and because it says first quadrant, this is just going to be 0 to pi over 2. So just reminding you that if it said first quadrant, this means that the angle changes from 0 to pi over 2. If they say second quadrant, that would be pi over 2 to pi. If it's third, that's pi to 3 pi over 2. And finally, if it's fourth, that would be 3 pi over 2 to 2 pi. But you can also make a parameterization from negative pi over 2 to 0. That would be another possible one. But unless you have a good reason why, I would just use these. Okay, so let's go ahead and figure out what is that f dot dr. So we take the first component of the force, which is negative 5x squared, and we dotting that with dx, or multiplying it by dx, and then plus the second component of the force, multiply that by dy. So this is the line integral that we need to compute, okay? And given our parameterization. Okay, so let's go ahead and substitute everything we know, and we're switching to a regular definite integral. So this is going to be 0 to pi over 2. Okay, so negative 5. Instead of x, we put 7 cosine t and square it. Okay, now remember dx is not just dt. This is differential of x, and x is a function of t. So this is really x prime dt. Okay, so what is derivative of x? Well, x is 7 cosine t, right? This is x, and then that's the other one is y. So derivative would be negative 7 sine t. Okay, plus, then we got 6xy. Okay, so this is going to be 6. Now x is 7 cosine t, y is 7 sine t, and dy, again, it's not just dt, it's y prime dt. So y prime, y was 7 sine, so this will become 7 cosine, and then we just add dt at the end. This whole thing is dt. Okay, so actually we will be able to simplify this further before we start integrating. So I've got 5 times 7 squared. Let's see. So 5 times 7 squared, some huge numbers. Okay, so 17, 15. And then we got cosine squared sine t. The two negatives cancel out, so that becomes a positive. Okay, then plus, here we have 6 and 7 cubed. So this is actually going to be 6. Wow, these numbers are not nice. But we got the same thing, cosine squared sine. Okay, so let's see if we can combine them because these are just like terms. So 1715 plus 2058. So I got 3773. This is a really ugly number. I'm gonna check that in a second to see if that's right. Let's do that. Okay, so yes, we got that. All right. So that's awesome. So we've got 3773, which we can just pull out and multiply the answer by it at the end. So what is an integral of cosine squared sine? So this is where the sine is odd and cosine is even. So unless both sine and cosine have even powers, you are using substitution, and usually it will be either sine or cosine. Well, how do you determine whether it's sine or cosine? Look at which power is odd. If they're both odd, then you can choose either one. But here, just sine is odd, right? Because it's power 1. And then the substitution is always going to be the other one. So the other one is going to be cosine. So then du will be negative sine t dt. So this becomes negative du. And then this becomes u squared. Okay, so this is going to be cosine squared will be like u squared du. So that's going to be u cubed over 3. So this is going to be cosine cubed t over 3. And the minus is still going to be there. So that's minus over here. And then 0 pi over 2. Okay, so first we plug in pi over 2. And cosine of pi over 2 is 0. So that part's 0. Then we subtract negative 3773 divided by 3. And cosine 0 is 1. So that's just going to be 1. Okay, so I think this is going to be 3773 divided by 3.